Hello guys, today we are going to start you the evaluate of the reference concept in CPP programming language, okay? And so we will derive the many examples about how we can use the reference notation in C++ programming language with the function especially for this lesson. But in the first place we should talk about how we can declare or define this concept in CPP, okay? And so as always I can give two command line in here, example 1, and so include iostream file in here like this one, using namespace std in order to what? In order to use this std namespace, and then I can give some return value because of the main has the return type of the integer types, and so I'm pushing the control F5 button in here like this one, and then I can select the C++ language with the G++ executable file in here and so I obtained the .vs code file, okay? Launch and compile task. Okay, so firstly we need to create some examples. For example, if we have the integer value like this one, this x is equal to the what? 5, okay? And so I can easily output this x value like this one, okay? And so if I run this code at the terminal page, we have the x equal 5. Because x is a variable with the type of the integer, so the RAM location we have 4 bytes in order to what? In order to represent the x value with the what? With the initialization value of the 5, okay? And so how can we utilize or define the reference? Firstly, we can select or we can define this kind of code in here, okay? And so we can also use the what? The ref value in here like this one, ref value like this one, and so if I run this code, the two values are the same with the others, okay? And so if I change this value as a 15, and so all the values in the what? In x is equal to 15 and ref is equal to the 15, okay? And so what happened if I change the x value in here? And so after the increment of the x value, if I run this code and print all the values, and so the x is equal to the what? The 16 value, okay? But the ref is the same. So what is the reference? Reference means that and defined by the what? These ampersand operators like this one, okay? If I use these notations, the ref is also an integer value but with the pointer type of these things, okay? Reference includes both the address of variable and its value as well, okay? But the normal variables like the integer x only includes variables include the what? The only the its value, okay? These are the basic difference between the what? The reference concept and the integer value or the normal type of the CPP programming language, okay? And so if I increase the x++ value with the what? With the reference point like this one, and so if I run again this code and then reference is also a 16 value. How we can obtain these counters in here, like this one? Firstly, we need to understand that the x in the first place, like this one, if we are using these things, and so the x and reference value are a different variables on this CPP language, okay? Because the x is equal to the 15, and so this is the right hand side values of the what of this notation or definitions, and so the x is replaced with the what with the 15 from the compiler usage, and so the ref is initialized with the what with the first value of the x in here. But if I use the reference point or reference definition in here, like this one, and so this reference imitates or copy whole of the features of the x, including what? Including the address value of the x and its real value in the type of the integers, okay? This is what? This is the definition of the reference concept. And so if we have this kind of definition in here, like this one, and so if we are increasing the x plus plus, or as is x is equal to the what is equal to the 16 right now, and so this reference value is also increased because the reference is not a different with the x. The reference is replaced with the x, including both the address value of this variable and its values, okay? This is the basic difference between the what? Normal type of the C integer, double, or the char character in the C++ programming language and or with the reference concepts, okay? And so if you have this notation in here, like this one, if we have the reference equal to the 1, okay? What will happen if I'm running this code? And so if I'm pushing the Ctrl F5 button in here, like this one, and so the both x and reference value is equalized to the what? To the 1 value, okay? Because the reference is the same with the x value, and so as or reference is updated or assigned to some variables, and so x is also assigned to some variables. But in the not usage of the reference concept in here, there are no difference between the x value while updating the reference, okay? And so the reference concepts can be defined by using the what? By using the address value of and its normal value or constant value of any variable, okay? We can easily replace the x with the ref or ref with the x. This is the first example of our session in here, like this one, and so we can add another example in here as an example 2, okay? And so in the previous lesson we have talked about the swap notation. As you remember, we can give the swap function in here, like this one, integer reference first, integer reference second in here, like this one. We can define the temp value in here first equal to the second, and second should be assigned to the temps, okay? And so if I'm giving the x2 y6 in here, and at the end of the swap operation in here, like this one, xy, we can see out the both values x y can be assigned at the at the end of this code. Okay, and so if I'm run this code, and so x is assigned to 6, y is assigned to 2, because we can give both the address value and its normal value to to this swap function. Okay, and so if I'm removing the ampersand operator in here like this one, and so this code gives us to 6, even if we call the swap function. That's wrong. But if I'm using the this notation in here like this one, and so we can swap the these values. First thing is important in here, because this x and y value are the local variable. Local variable means that it's only current in the in this region or in this parentheses. Okay, and so if I'm defining this value, and so if you have this information, and so if we want to transmit whole the information, its values, into another place or another function, we should use either pointers or the reference value. Reference value cannot be included in the C programming language. It's the addition to the CPP programming language, and so it's much safer than the pointers. But the pointers has many options to manipulate your codes in order to reach some address points. But if you are using the reference concepts like this one, we don't have the many errors in your codes, okay, or less errors. This is the basic difference of this thing, but the reference concept is a highly complicated parameters in here like this one. And so if we have this example in here like this one, and then we should give some specific examples in here. Firstly, we should debate the reference concepts. Int x equal to the 5, okay, and so int reference ref1 is equal to the x, int reference ref2 is equal to the x, int reference ref3 is equal to the x. Okay, and so cout value x and Lee, and so I can copy off all of these things in here like this one, ref1, ref2, ref3, ref1, 2, 3, and so if I'm running this code, and so the ref1, ref2 and ref3 is also assigned to the 5, and so the variables can be defined or indicated by more than one reference notation. Okay, and so what happens? Ref1 is increased in here, and then the whole values is increased. Okay, ref2 increased, and so ref3 decreased and x decrease. If I'm using these notations in here at the end of this code, x or ref1, ref2 and ref3 is equalized to the to the 5 value. Okay, this is the third example of this session, and so we can easily say that the variables, any variables that defined in the CPP programming language can be indicated by the more than one reference notation or reference values. How can we use this information in the real life applications? For example, we can design the controller in the car or airplane, and so everyone or every components can call or can use the motor speeds. Okay, but the cockpit or the airplane heading motion uses these values as a thruster or the force diagrams, and so we can set the new name in here like this one: integer, reference, thrust, motor speed. Okay, or we can use this, the longitudinal motion speed. Okay, at the same time these two values are the same, but we have the many microprocessors or the processors on the on the airplane or the car or the computers. Okay, and so even if this value is the same with the with the measured value, in the first place, or the thrust motor speeds can control the motor speeds. Okay, and so we can easily set this name by using these reference concepts in order to easily understand what we are writing in that code. Okay, and so many include files or many source file can be used in the design of the controller of the car or airplane, and so we should name, or we should give some specific names in order to same variables or represent the same variables. But if we are using the whole components this x, it's meaningless. But if we are using this thrust motor speeds or longitudinal motion speeds, more meaningful to process whole the information coming from the x. But in the real application, x is the same. This thrust motor speeds or the longitudinal motion speed is the same. Okay, but in that situations we can easily indicate what we are using or what we are going to have or need it to be in order to design your controller. Okay, and so this is the third example of our session. We can copy all of these things in here like this one. Okay, it's the example 4. Okay, what happens if we rotate the ref1 and ref2 variable in here? If we can use this x value with a reference point in here like this one, and so the reference must be referenced in the CPP programming language. Okay, and so I'm deleting the executable file in here, and then if I'm run this code, all the values is equal to is equal to 5, but ref3 is increased in here like this one, and so all the values is updated. And then we can conclude that the reference values could be referenced, could be taken as reference as value. Okay, this is how we can use the reference value in here like this one. Okay, and so this is the fourth example in our notation in here. Okay, this is the fifth or 5th example at this moment. Okay, and so we need to evaluate the function reference concepts right now. Okay, firstly I'm giving the integer func value in here like this one. Okay, integer x value is equal to the 10 and return the x value in here. Okay, and so we can call the func value in here like this one: func value func, and so if I'm run this code, the func value returns to what? Returns to 10. Okay, what happened if we are using this notation in here? In the first place, the func value is return type to the what? To the x value in here. But the compiler tells us the expression must be a modifiable L value. What is the L value and right value or R value? Left value is that we can combine the whole information in order to what? In order to storage to this kind of values. And so as a consequence, we can use the L value in order to what? In order to manipulate its value or address value with the what? With the increments, division, or the some basic multiplication or mathematical operations can be obtainable or can be performed or on these L value notations. But the 5 otherwise is a right value or R value. What's the meaning of the R value? R value, you can think that the R value is always a constant value. Okay, the 5 cannot be changed in the whatever we are using the compile time or the runtime operations. Is a constant or literal value. Okay, we cannot manipulate the 5 values or any other const value in this notation, and so we can call it the R value. Okay, right hand side value. Okay, but if you are set this func with the return type of the what? The reference value. If we are using these notations and then if I'm running this code, the func is giving the what? The exception has occurred in here. Okay, but what's the error of this function? The compiler tells us the int x, the reference to local variable, is returned in here. What does that mean? You are using the int reference value in here, but the x is not a reference value. Okay, if we have this kind of information, we can use the reference in here like this one. Okay, and then the error is gone or missing right now. If I'm run this code again, and so we have the problem, cannot bind the non-const L value reference of type int reference to the int. Okay, okay, we cannot represent the what? The 10 or right value into the what? The reference, because the 10 has no address point on this compiler notation or the RAM locations. We should always use the what? Use these things. Int y is equal to the 10. Okay, and so y should be equalized these things, and so if I'm run this code and then the func value is equal to the 10, but there is no syntax error. These are the awkward parts of this CPP programming language. But if I'm change this notation in here like this one, and so the executable file should be deleted in here in order to recompile of your code, and then we cannot compile this code because the L value required as a left operand of assignment. But if I'm adding to this notation in here like this one, the func value is always 10. Okay, how can we use this specific notation in here? If we are using this code, this is the what we can comment of this line. If we are using the non-static or non-local variable like this one, static int x value is equal to the 10. And so if we have this kind of representation in here, we can return the x value in here. After that, if we are using this code in here, the func value is normally equal to 5. These are the interesting points of the usage of the reference usage. In what? In CPP programming language. If the x value is not a static variable or non-local variable like the static definitions, and so we can return this x value with the reference point, and so this as x is created in here like this one, and so this func value can be assigned to the what? To the 5. But in the background, this func values represents only the x value in here. For example, if we have this kind of information in here, and so this is equal to the what? Equal to the assigned these things. Okay? And so if I'm run this code, and then the x was not declared in these scopes. But if I'm using the func function, because the func is seen on this page, and so if I'm running this code, and then func is assigned to the 5. Okay, if we have this kind of information in here, we can also call this func notation like this one: func times func. And so if we have this information, and so func value is equal to the 25. It's the interesting point of the usage of these notations or the reference concepts, or we can assign to the minus func body in here. But the compiler sees this definition in here like this one: x is equal to the x times x minus x. Okay, but in the usage of these things, the func or this function definition only represents the x value at this moment. Okay, this is how we can use the reference points on the CPP programming language. And then we will move to some advanced example in here with the usage of the function notation. Okay, and so we can delete all this information in here, and then we can build a new example. Okay, and so firstly we need to add the int reference x value in here, and we can return the x value. Okay, yeah. What happens if we call this function like this one? Okay, and so the x value in here like this one. Okay, if I'm run this code, and so the func value is equal to the 20, but the previous executable file is in here, and if I'm run this code, this file gives us to the 10 value as an error, because we have the reference point in here, and we can return the int reference value. Okay, and then if we say that this 10 value in here like this one is assigned to the to this value, and so the compiler tell us to the int reference x cannot be equalized or initialized with the what? With the 10 value in here, because this is literal or constant value or r value in here. But the definition of these things is okay. And so how can we overcome for this error? If we have integer x value in here or a value like 5, okay, integer reference or a value can be assigned at this moment. If we have this usage in here like this one, and so the x return to the what? To 5 value, but we cannot assign to the what? To the 10 value in here, because it's the same with the what in the x reference equal to the 10. Okay, this gives an error because the 10 cannot be manipulated by the compilers because it's a constant value, and so the reference cannot be equalized to the what? To the 10. Okay, and so how can we redefine this a variable in here? Firstly, I can show you a value is equal to the what? To the a endly. Okay, if I'm run this code, the x and a value is equal to the what? Is equal to the 5. But what happens if we multiply the x times x in here like this one, or this x plus 5 in here? If I'm run this code, and so the main executable file should be deleted in here, and then we have syntax error. Initial value of reference to non-const must be an L value in here. Okay, which means that the x cannot be increased or decreased in here. But what happens if you are using this notation in here? If I'm run this code, and also we have the what? The L value reference in here. Okay. We can say that we can return this x value in here with what? With the usage of this notation in here like this one, and so there is no syntax error in here, but we cannot increase this x value in here. But what happens if we initialize the int y value in here, or int reference y value in here? And so y plus plus can be added in here, and y is increased at this moment. And so if I'm using this notation, voila, the x value is increased to the what? To the 6, because the int reference value is assigned to the what? The x, and y is increased and return y with the definition of int reference value, and so this func returns to the x or 6 value. But also a value in here is what? Is 6 value or 6, because this a, this x, this y are using the same general notation or general location on the what? RAM storage, because the reference points both includes the what? Address and its normal value. Okay, and so what happens if we are using the int reference z value is equal to the a, and so z or z plus plus at this moment? If I'm using this notation in here like this one, the both x and 7, x and a value is updated. Okay, And so what happens if we are using this notation in here, like this one? And x gives us to what? The -1 value. But the func a is what? Is given other value. Okay? Firstly, we need to understand that the z is equal to the what? Is equal to a value. And so at this point, this equalizes to the what? This equalizes to the 6 value. But after the func operation, this z should be updated because if I'm using this normal z and value is written on this page, the x value is equal to the what? Or z minus func a value is equal to the what? The -1. A value 7, z value is 7. Okay? But the z or a or y or x are the same variable in here. What happens in this code? In this code, the func a variable is updated. Okay? Is updated in here like this one. And so this return y value is equalized to what? The 7. But in the first place, if we have this subtract operation, or if we have the same line operation in here like this one, the z value is not increased at this moment. Okay? Because the func a is updated right now, but the z is not, even if the z or a are the same variable. You should remember that. Okay? Because in the otherwise, the z and a value is equal to the what? Is equal to the other things, and so this gives us a 0. Okay? Because the int reference return type in here and y should be equalized to what? The a. What happens right now if you have this kind of notation? There are no difference in that moment. Okay? Or what happens if we change this a minus func z notation in here? Is also gives us the -1 1. What happened? A plus plus should be added in here like this one. If we have this kind of information, and also a give to -1, but the a or z value is equal to the what? The 8. Okay? Or y value is equal to the what? And li is equal to the what? The -1. Okay? And li and d. Okay? And so if we have this information in here, the y is equal to the what? Is equal to the same a value, 8, and so func z value is equal to the 7, and so it gives us the -1. Okay? But what happens if we are using this notation in here? -2. So this relates to the what? It's related to priority level of the what? Of the code running on CPP programming language. Okay? If you have this kind of information in here like this one, and so the reference can be returned to the what? To the different values, even if the z, a, y or x value are the same. Okay? This is the exceptional point on what we are using, the what or how we are using the reference notation on CPP programming language. Okay? And so this is the last example relates to what the reference notation or reference concept on CPP programming language. you should iterate your knowledge by using this, solving the many examples about how we can use the reference concept on CPP programming language instead of the pointers. You don't know the pointers knowledge in here right now, but don't worry, you should only focus on the reference concept on CPP programming language. Okay, see you guys. Hello guys, today we will perform the third lesson of the C++ example session, and then we are gonna talking about what's the pointer and how to use pointers in C++ programming. So, as you know, every variable is a memory location or has a memory location, and every memory location has its own addresses defined by the compiler or the C++ programming language, and we can access these variables we are using the ampersand operator. As you can see in the example of this code, int main function return 0, we can define a variable like that, and we can access its address variable like ampersand operator by a variable definition in here. So we can run this program, and we get the following address by pointing a variable like that: 0x blah 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 FEBC. This address shows us the memory block or the memory address of the a variable in the program or in the compiling version. And so a pointer is that with this notation we can comment all the things and we can write all the explanation in here. A pointer is a variable, but it's a variable whose value is the address of another variable in C++ or in C programming language. So we can define a pointer value or pointer type, and then we can point this variable or this notation of the a in the programming language or in the programming code. Like in main scope, we can define a pointer value or pointer type of variable, and then we can store or we can take or we can obtain this address value as a variable. And so we must declare a pointer before you can work with it, and the general form of definition is that like this: int asterisk operator, or for double variable double asterisk operator, or float value float asterisk operator. There are many definitions for the pointer or the pointer usage because each of the definition has different byte storage. Like in C++ programming, integer is 4 byte and double has a 8 byte, which means that if we define a pointer by using this notation, and then we can know that this pointer shows or points to the double or integer value. Otherwise we get an error from the compiler because it's a syntax error. So we can define related pointer in here via using the integer asterisk operator and with the name of a ptr, and we can assign a ptr to address or ampersand of a, which means that this is a variable storing value, and it's also variable but storing address value of the memory, pointing a variable in here. And so we can write it down a ptr here, and then we can run it by pushing the Ctrl F5 button, and then a address is 0x blah 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 feb8, and then in order to compare the both variable, or in order to prove that the aptr is equal to the ampersand a, we can write it down as and lia, and then we can compare all the things in the terminal code clear, and we can run it down, and it's also is equal to each another one at that point. Okay, so we can use it like that, but we can define another pointer value in here, bptr, and then bptr cannot store or cannot point the integer values like that. If we are using this notation, and then the compiler tell us a value of type int star or asterisk cannot be assigned to entity of type double star, which means that each of the pointer values points or shows the variable with the type of its related type, which means that if you're gonna use the double variable or double pointer, then we can only assign or only show the double variable in the memory block like that, double b 5.2, and bptr can be assigned now double b, just like that. This is the first example, and it's the mechanism of the pointer, and we can also learn how to use it in the main function block, because the main is a scope variable, or the scope has a scope function, and we can define all kind of variable in here, but we can also define pointer type of variable in that scope, and so we can transfer all the variable or all the variable type itself to another function by using the pointer, because the pointers has a memory address, and so it's universal or it's general for every function of the C programming language. So if we're gonna give some variable to the function or another function, then we must use the pointer notation like that. This is the first example of the pointer usage, x1 in here, and now we can pass, or we can next the another example in here. So we must include the IOStream again for the cout class usage using namespace. std should be added in here, and then we can write it again, return function to show where the program is start in the address memory block. And so at the previous lesson we have learned how to use the function and how to define a function block in here, but we cannot learn how to use pointer to transfer any function or to transfer any variable to another function. And so we can define a variable in here, integer a equal to 2, and we can write it down as by using cout operator at that point, and we can run the code and we have a is equal to 2, and we can define some function in here, void change variable value. It's the name of the function, and its function is that this function changes all the variable value with the parameter of integer a and int specific values with value. So if I use this, or if I use this function with these parameters, and I can update, or I should update the value of a with the value of the entering point. Okay, and so I can implement these things with the function definition block and a equal to value in here. In this usage, or in this function block, we can write, or we can implement in the main function, or we can call this function in the main block with the parameter of a with 5 value. And so cout a must be equal to 5, because I initialize the a variable in here, and I can output all the variable value to the screen, and I'm calling now the change variable value function with the parameter of a, and the change variable value must change the value of a with the value parameter. Okay, and then if I output the value of a, at that point I must see the a is equal to 5. Then I can run this program, but a is not changed at that point, because we give the function to the value of a at that point. But in order to update, or in order to reach the real a value or real a itself, we must use the pointer values, just like that. aptr, and then aptr must be equal to address of a at that point, and then we have a memory location in here with the variable aptr, because aptr points to address of a at that point. So we must update the function of change variable value, and then aptr should be added in here, and then we must update the function definition block in here. So asterisk a must be updated value of the a variable, because it's address, and then in order to obtain the real value or integer value of the a, I must use this syntax rule, like left-handed operator should be added to the a variable in here. Okay, and then at this point the program starts with the definition of a equal to 0 and the definition of the int star or int pointer type aptr, and then I can update, or I can equalize the address a to the APTR, and then a must be written at that point, and I can call the change variable value with the parameter of address of a and the value which I can assign, or I must assign to a value. Okay, and then if I gonna use, or if I gonna output the a variable at that point, and a must be changed with the parameter of 5 or value notation in here. So if I run this program, and then we get 5 value for the a variable. In the previous example, we cannot change the value of a, but if we are using, or if we use the pointer type, then we have memory location of the a, and then this code has a universal property to assign or to update any variable by using this operator. And then if we run this program with the pointer type, and we can call change variable value with the pointer, and then we must obtain the value of the a because it's a pointer type, and then we can update, or we can assign the value to the a location in the memory block, and then we have the different value of the a with the parameter of value, which means that it's equal to 5, and we have updated all the variables. So pointers, give a chance to update another variable in another function block in here, because the memory blocks has or have addresses, and they are all the same feature, which means that they are universal, which means that it's not dependent to it does not depend on the what the variable type, or what the variable value of the main blocks function in here. So we can use pointers to update or eliminate or remove or add any variable in the programming language at that point. But the main feature of the pointers is the universality. We can use in every blocks, or in every function, or in every files, because the memory shared by the whole programs or whole programming languages. So in the next lesson, or in the next example, we will discuss about how can we use the pointer in arithmetics, or how can we use, or we create the loops of the pointer, which means that we have some properties about the, or related to the arithmetic notation, plus plus or minus minus operator at that point, and then we should revise the definition of array with the pointers, with the insight of these knowledges given here. And now we are gonna talking about the pointer arithmetics. And you can imagine that the pointer is an address in memory block which is a numeric value. So you can perform, or you can do arithmetic operation on a pointer as you can a numeric value, like we can increase the value of a because its type is integer value, but in pointer arithmetics we can also increase the value of pointer in here. To understand the pointer arithmetics, the ptr is an integer pointer in that case, and which points to address, for example, 100, and assuming that the pointer has 32-bit integers, and also we can learn the pointer bytes in this system just like by using the size of operator in here, like int star in here and leave, and then we can run it down, and we have the 4 bytes in here for the pointer values. So we can assume that all the pointer types in this compiler or in this compiler rule has 4 bytes, which means that 32 bits for integer. And so if we can use the arithmetic operators in here, and we can expand the example by copying the whole code x3, and we can comment all the things in here like that, and we can write the pointer value in here, apt3, showing the value of a or the location of a, and we can increase the pointer value at that point, and then we can also writing down aptr in here. So we are gonna expect that the pointer must be increased with the value of y at that point, but the results show that FEB8 and the FEBC at the next pointer value operation, which means that if we increase the pointer value with 1 and then we add the address location 4 bytes for the integer value. So if we define the double value in here like 2.2 and double asterisk or double star operator bp3 shows or points the double b variable in here, and then we can also repeat all the equation for bp3 value, and we can also increase the value of bp3 at that point, but double has a 8 byte in this system, so we can run this program and we see that for the integer values there are 4 byte difference for the increasing 1 point, but in double types we have the address of FEA8 at that point, and then we increase the value of the pointer with 1, and then we add the 8 bytes for the double operator in the pointer of double in here, which means that we can assume or we can prove that pointers has a arithmetic operators, and then we can add or subtract specific values, but if we increase the 1 value of the pointer, and then it has the bytes of, or it has the increased bytes of the integer value. So if we increase the integer pointer with 1, then we forward 4 bytes. If we update, or if we increase the double values in that system, or double star values in that system with 1, and then we forward 8 bytes at that point. So if you're gonna use this notation, then we can define the array arithmetics or array dynamics in that system, because in the 5 example or 4 example, we can comment all these things in here. We can define array elements with this notation, or 3 elements, and we initialize all the values of a like that. But array of a starts a specific address value, so which means that a is a pointer type in that notation. So int star aptr can be equal to a, or can be assigned to a value, because a is a pointer type, because it has a memory block, or it has a specific address for this compiling operation. So we can write a 0 value with the parameter of a, as we learned in the previous lesson. But we can also reach a value with the operator of asterisk at the left hand, just like that. So we can reach the value of a by using this notation in the array format, but a is a pointer which pointing the start address of this array notation, and then if aptr is equal to the a, and so aptr points the start of the array elements in here. And so if you're gonna take the inside value, or the obtaining value, by using this notation, then we should have at the output with the same number of values related to the a point. And for example, we can start the program, and a0 is equal to 1 and is equal to 1. So we can change all the notation by using this dynamics in here. But if you're gonna reach the second value of this array, and then we must use this notation, because a1 is the second address operator in that array block, and then the pointer must be added to 1 to reach, or for reaching the second element of this array. And so we can run this program again, and a0 equal to 1, a0 equal to 1 from pointer, and a1 is equal to 2 at that point, because we have initialized by this value, and then aptr with addition of 1 parameter, which means that 4 bytes is forward to the array element, by using this pointer value, and then we get a1 equal to 0. So if we can, or if we try to write all the elements of the array, we can use this notation with for loop cout a e, and we can add this notation and li. So if we're gonna run this program, and then 1 2 3 is written on the screen page in the terminal, and by using this notation, or knowing that the pointer must, or pointer has an arithmetic with the increment or decrement values, so we can display all the elements by using this pointer notation like that. aptr plus I, so this is the address operator, and then we can take the value of the aptr storing in the memory just like that. And so both code are the same in terms of the function properties. So we can run this program, and then we have the same values or the same elements of the array notation in here. So we can use the pointer to reach or to eliminate, to add or to change all the elements of the array in the C++ programming. So array is a fixed sized elements of the integer value in C++ compiler at that point, but also a has a specific address location in the memory block. So we can reach a elements or a location by using pointer arithmetic in here, just like that. Okay, and this is the most example, also it's the most important example in C++ programming. And then we can add the pointer to some specific integer values, but we cannot add double value or float value in here, because the expression must have integral unscoped enum type in here, which means that the pointer or the address operators is or has always the integer property in the C++ compiling system. Okay, and so we cannot assign or we cannot add to double points or the float number or the string character to the pointer values in C++ programming. You should remember that, because it's an important property for the using of the pointer arithmetic. And so at the next example we will focus on how can we passing pointers to function in order to functionalize, or in order to create a function to display array or change array or initialize array by using the pointer notation in another function block is in here, because we have said that the pointers has a universal property, which means that it's an address operator to locate or to point or to show the specific memory location, and we can use pointer to reach any variable in the memory block in another function in C++ programming. And so At the next lesson, we will try to create a function to display or to initialize the array elements of the main array block in here. And now we should implement the array operation on the function or the passing function values as a pointer in that location. So we can comment all these things as well, and we are gonna next the example 5 in here, include IOStream, and using namespace for std class in here, and int main std namespace in here. Sorry guys, return 0, and we can define integer array in here without initialization process. So we should define a specific function in here like initialize array with the parameter of a and size operation, and we should define size as 5, and we can replace the 5 with size variable in here, and we should define void initialize array declaration. At that point we should give the function to the int star value in here and integer value at that point. And so we can display array by using pointer arithmetic in here, just like that, and we should declare all the function values at that point, function declaration, and we can also give display array with the parameter of int star and int for the size value. And so we can implement or we can define the function block with the function definition notation in here. Okay, void initialize array with parameter of int aptr as a function parameter and int size as a function parameter, and it's showing that the size value or the length of the array operation. As for difference between the pointer arithmetics, we can use this notation. In the for loop, the first value is the initialization block. So we can use the pointer to search or to loop every points of the a variable at that point, which means that we can create a loop by looking the increasing pointer values or decreasing pointer values at that point. So if we have a ptr pointer in here smaller than a ptr last pointer, we can use this notation with the definition of int star a ptr last must be equal to a ptr size minus 1, which means that the last address of an array A in here. So we can also increase the aptr pointer because we have all arithmetic operators in here except the product and division, they are not current, or they are not to be used in pointer arithmetics, but in this notation we can initialize all the array elements by using the pointer arithmetics in here. And so we can reach the value of APTR, and then we can update its value with the definition of integer e equal to 0, and then e equal to e plus 5, and we can assign I variable in here. Okay, and then we can write the display array function in here in different way. We have the last address in here. We can use the while loop. At that point, APTR smaller than APTR last. Then we can use a and with the parameter of e, and we can add these things in here, and then we can reach the APTR address elements. At that point, APTR is an address, but asterisk or star APTR, it's integer value stored by the address, specific address memory operation. Okay, and so we should increase the integer value of e at that point, and then we can test the whole algorithm in here. So by pushing Ctrl F5 in here, and then the loop has not ended at that point, because looking that we cannot increase, or we did not increase the value of APTR at that point, and so we should add this notation in here, and then we restart the program. And so A0 equal 5, A1 equal 10, A2 equal 15, A3 equal 20 at that point in here. Now we can change the size variable in here, and then if we restart the program, and there are two values at that point, but the length of the array is, or the size of the array is equal to 3. So we have a problem in here, because we can change this smaller operation with this notation, because the APTR last has a specific memory on the array A. So we should update these two things, because the APTR last is an element of the array notation, and we can restart this program by using this notation. Then the program is okay in here. So this is a different idiom for the loop and while loop notation, and so we can compare two pointers by using logical operator: greater, smaller, equal, then blah blah blah. Okay, and we can search every parameter of the pointers by using this notation in here. As an example, we should not require this points at that point, because we can also update pointer value at that point, and so we can restart or rerun this program, and A1 A2, A3 updated with this notation in here. Okay, but we have different values in here, so because we have an error value at that point, so APTR at the next point points to second elements of array, so we should add this notation in here. 95 is a garbage value at that point, and so we restart the program by pushing Ctrl F5, and then we have the 5, 10 and 15 elements of the array in here. Okay, now we can expand the whole program by adding the sum and min function of the array, but we have a different approach to calculate it, because we know, or we already know, the pointer arithmetics in here, and then we should implement the sum and min function by using this notation at that point. In the next lesson we will try to cover up, or we will try to create just like this program notation by adding the sum and min function in the next lesson. Now we can add the sum function with the parameter of sum array and int star for array value or array name, and int star for sum value, and int value or int type for size function in here. So void sum array with the parameter of int aptr and int star sum ptr and int size for the parameter of the function. And so we can use this diagram in here, integer or int sum is equal to 0, and then int while aptr plus plus for increasing pointer address, and aptr last value for the pointer, and then sum plus sum yıldız aptr should be added in here, but with some additional values at that point. And so we should also define aptr last pointer at that point, last, and aptr size -1, and we can update some ptr value with the address of sum or some definition in here. Some ptr is a pointer address, but if we're gonna take the asterisk operator, if we're gonna use the asterisk operator in here, its type is equal to integer value of pointing address of some ptr value at that point. Okay, and so we can use this notation in here with the parameter of aptr or a value, and we should add some ptr address at that point, and we're gonna use size definition in here, but we must define some ptr address in here. Okay, sum array should be updated at that point. And so we can use the sum of the array value. We can use this strings notation, and we can reach the sum ptr address at that point, and we can add AND operator at that point. And so if you're gonna run this program, we should get the 30 for the summation of the array, and then we can test the program, and then exception is taken in here because sum ptr is at the garbage value, and so we need to reorganize this code with the definition of int sum equal 0 for the integer value, and then we should assign sum address at that point. And if we're gonna restart the whole program, and so sum of the array is getting 30 value in this notation. At the previous example, there is an error because we have an error since we have no address pointing at the variable of sum ptr, because we should store, or we should address some specific point located at the memory, and we should store some specific address value for the integer variable. So we need to 4 bytes to point the start address of the sum, and we can only use the sum ptr at this notation because in the first place int star sum ptr is a garbage value. It didn't point anything in the memory block. That's why we obtained we are getting the error at the previous example. Okay, and with the same analogy we can calculate the mean value of an array, and so we should define this notation with the same parameters. However, the sum ptr or mean ptr at this example should be changed with the double star value, because the mean has a floating or double points in the memory, like 1.2 or 2.5 at this notation. Okay, and so we can define double star mean ptr with the parameter of address mean value, and we should define specific address in the memory block with this notation, and we should change this notation in here. And so we can use the same analogy in here to calculate the total sum of the array, and then yıldız mean ptr should be equal to casting by double operator at that point, and sum divide size giving us to mean value of the array at this point. Okay, and so we can use, or we can call this function at that point. So we need to pass a value at this point, and then mean ptr should be given in here, and size of the array should be given in here. And so we can copy these things, and mean value of the array is equal to mean ptr values. So we can test the algorithm, and then the sum of the array 30 and the mean value of the array 10, because its size is equal to, or is the 3, and the sum of 30 and 30 over 3 is equal to 10. So it's correct, and the program is okay for the implementation of the pointers and array operations. And this is the last example of this session. At that point, have a nice day.